In today's lesson, you will learn to solve equations involving radicals. You must be careful to follow the strategy exactly when solving radical equations. You must isolate the radical first, or you will get a wrong answer. Even after following the procedure correctly, you must be careful to check the answers. Since the square root of 25 could either be a positive 5 or negative 5, and since the symbol, the square root symbol, always refers to the positive root, one can get extraneous roots. That means one can get answers that do not check. So one thing about radical equations involving even indices, you must check. Now if you have an odd index, the check is optional. But if you have an even index with a radical equation, you must check. You may end up getting solutions that are really not correct. So one must check. The square root of 2x plus 3 minus 5 equal to 0 is an equation involving a radical. Notice we have the radical, the square root of 2x plus 3. We have an equation. Since one cannot have a negative radicand with an even index, that is within the real numbers, one must restrict the set of possible solutions. So going back up, we have an even index, which is understood to be 2, and we have the radicand 2x plus 3. One cannot have a negative radicand, so 2x plus 3 cannot be negative. 2x plus 3 must be positive. We must restrict the set of possible solutions. In fact, we must restrict the set of possible solutions to 2x plus 3 is positive or 0. So notice the radicand is 2x plus 3, so I would have to restrict my solutions to 2x plus 3 is greater than or equal to 0. Well, if 2x plus 3 is greater than or equal to 0, then I can subtract 3 from both sides to get 2x is greater than or equal to negative 3. The 3 minus 3 gives 0. 0 minus 3 is negative 3. Now I divide both sides by 2 to get x is greater than or equal to a negative 3/2. In other words, we are restricted to answers greater than or equal to a negative 3/2. If you were to solve an equation and get an answer such as negative 5, you could not use it. Negative 5 is not an allowable substitution. If you were to substitute negative 5 into this square root symbol, you'd have 2 times a negative 5 is negative 10. Negative 10 plus 3 is negative 7. And the square root of negative 7 is not real. Now, let's solve the radical equation. 2x plus 3 minus 5 is equal to 0. The first thing I want to do is to get the radical by itself. So I'm going to add a positive 5 to both sides to get the square root of 2x plus 3 is equal to 5. To get rid of a negative 5, I need to use a positive 5. So I added a positive 5 to both sides. The negative 5 and the positive 5 will cancel from the left side to leave me with the square root of 2x plus 3. The 0 plus 5 gives 5 on the right. Now I can square both sides. If I square the left, I get the square root of 2x plus 3 quantity squared. And if I square the right, I get 5 squared. So I have followed the golden rule of equations, which says do unto one side as one does unto the other. So I squared the left, therefore I must square the right. Now when I square the left, I will simply eliminate the radical. Now let me show you why. The square root of 2x plus 3 can actually be written as 2x plus 3 to the 1/2. Remember, the square root can be the same as the exponent 1/2. So when I square now, that means to raise a power to a power, I need to multiply the exponents. So I keep the base, the 2x plus 3, I multiply the exponents. 1/2 times 2 is 1. Now when I square 5, of course, I get 25. So we have 2x plus 3 to the first is equal to 25. Now 2x plus 3 to the first is just 2x plus 3. So I have 2x plus 3 is 25. So notice that squaring simply eliminated the radical. Squaring eliminated the radical. Because the radical means, the square root means exponent 1/2. To raise a power to a power, I multiply the exponents, keep the base. 1/2 times 2 is 1. So the end result is that squaring simply eliminated the radical. Now of course 5 has no radical with it, so when I square the 5 I get the 25. Now I subtract 3 from both sides to get 2x is equal to 22. And finally I divide by 2 to get x is 11. Now let's do the check. I'm going to check x is equal to 11. The problem is the square root of 2x plus 3 minus 5 is equal to 0. Replace x by 11. So I have the square root of 2 times 11 plus 3 minus 5. Now do the multiplying. 2 times 11 is 22. Plus 3 is 25. So I have the square root of 25 minus 5. The square root of 25 is 5. 5 minus 5 is 0. So we can see that the solution does indeed check. Now I'm going to give you the rule to learn, and you need to follow this every time you solve an equation involving a radical, or to solve radical equations. The first thing you want to do is to note restrictions. Remember, you cannot have a negative number under an even index. So you cannot have a negative radicand with an even index. So you must note those restrictions. The second thing you must do is isolate the radical. Now this is probably where most people make mistakes. They just forget to isolate the radical, but you absolutely must isolate the radical, which means get the radical by itself. The third thing you do is raise both sides to the power needed to eliminate the radical. So once you isolate it, your next step would be to eliminate it. And you raise both sides to the power needed to eliminate the radical. Now if you have a square root, then you're going to have to square both sides. If you have a cube root, you're going to have to cube both sides. Now once you eliminate the radical, then you simply solve the resulting linear or quadratic equation. Just use the normal means. To solve a linear equation, you want to get the x or the variable by itself. To solve a quadratic equation, you want to put it in standard form and then try to factor. Now step 5 is critical. You must check all solutions to step 4. Now this is required. You must check all solutions to step 4. And then you give the solutions that check as your answer. So make sure you memorize this procedure, and every time you do a radical equation, follow it. As I do some examples, I'm going to actually number each of the steps so you can see what I mean by following it. You might want to number them on your homework as well. Let's look at another example now. Give you just a minute in case you need to catch up on copying. Okay, let's look at another example.